Alright, in this lesson here we are going to go through the first couple of boxes of in setting up your Unit 2 summary. So for starters here, I've got my template page. First thing I want to do is fill in the unit. This is Unit 2. Title of this unit was Exponents. And of course my name goes up here. And there's the rubric, and now I'm ready to start doing my summary down here. So what do you put in your summary? If we go back, remember what goes on your summary: topic, rule, example, explanation, connection, and it's helpful to indicate where you're making connections with a little star. So we put all that together. Remember, tree, C star. So the first box in the guide was algebra. Underline that. Now, what did we learn in algebra? Well, we might want to summarize a little bit here. We learned that if we had something like this, 4x plus 3xy squared, this is an expression. And each of these things here, the 4x and the 3xy squared, were both examples of terms. So term and a term. So just a little bit of a couple little definitions here. We also learned that if we had something like 2y equals 3x plus 4, because this had an equal sign in the middle, we called this an equation. Okay. Why was it an equation? Because of the equal sign. So we should say, yeah, let's just say because of equal sign. So in these things here, I've got my topic up here. Okay, I've got kind of rules here. Like because of the equal sign is a rule for deciding if something is an equation. I've kind of got definitions, but I definitely have examples of everything, and I've got a little bit of explanation about why these are examples of these things that I'm saying that they are. The next thing we might talk about is we might want to, explain term in a little bit more detail. So a term was something like, I'll give another example, and we might want to talk about the parts of a term here. So I'm going to switch colors here just to make things a little bit more organized. This number out in front was the coefficient. These letters in here, I called them variables. The learning guide called them literal coefficients. And of course, the 2 up here is an exponent. And then there was also some work in the guide and the lesson on converting words to expressions. So we can just say converting words to expressions. So we could just give an example here maybe. And there's no real rule that we can follow when we're doing this. So an example might be 4 more than, say, half a number. And I might say that this is equivalent to, well, there's half the number, n divided by 2. The 4 more gives us a plus 4. Or we could write this as 1/2 n plus 4, something like that. Now notice I didn't choose like the easiest kind of example for converting words to expressions. I could have just done, 4 more than a number, but I chose one instead that has 2 operations in it, 4 more and half. And one of the ones where, sometimes people forget what is meant by a half or a third or triple. So when you're putting your examples in your summary, it's often better to choose sort of trickier examples than really simple examples. And we're going to see this as we go on to the next section here. Section B, powers is my topic. And we started with a little bit of, again, with some definitions. If we had something like this, we knew that this whole thing here was called a power. This thing right in here was the base. Okay, and of course, this up here is the exponent. I think this picture just like this was right in your learning guide. We could use this same example to say that what this means, of course, is negative 3 times itself 4 times. Whoops. And I wrote a 4 there instead of a 3 because I was saying 4, but I really meant 3. Okay? And we know that we called this expanded form. This over here was power form, or exponential form. So we'll just say that this is power form. And we could also evaluate this thing. We know that this thing evaluates to, let's see, positive 81. Okay. And a connection that we might be able to make here is that when we're expanding this, going from here to here, we got to remember those integer rules. From 1a, we've got a negative, a negative, a negative, a negative. 2 negatives go together to make a positive, so we've got positive times positive, which is going to give us that positive answer there. If we wanted to, we could also put in another example, maybe using fractions. 2/3 to the power of 3 is going to be 2/3 times 2/3 times 2/3, which is going to be, well, multiply the numerators and get 8, multiply the denominators and get 27. Now, so this is just an explanation of what powers are. We don't really have, we have sort of a rule implied here in that you're using integer rules to evaluate these powers, but this is more an illustration or a definition of what powers are. The big thing you're going to want to have here in this section is these tricky ones, what the learning guide called special powers. Okay, so these are the ones that people often make a mistake on. So as you're going through the learning guide, if you find a question that you get wrong, it might be worthwhile to put it in your summary on this little section here. So something like this. Remember, if we've got negative 3 squared, the base is negative 3. So we do negative 3 times negative 3. Negative times negative gives us positive 9. We usually don't write the positive, but I'm going to write it there just to make it kind of a contrast. If we see something like negative 3 squared, because there are no brackets there, our base here is just 3. And we only have one negative sign. So that negative sign goes out front, and then we do our exponent, or evaluate our exponent. So this is going to be negative, and then just 3 times 3, which is going to give us 3 times 3 is 9. Then we apply the negative sign, negative 9. Other special ones that you might want to include are these ones involving base 1. So if you've got something like 1 to the power of 5, you know that this is just going to be 1, because it's actually 1 times 1 times 1 times 1 times 1. 1 times itself just keeps giving you 1. So 1 to any exponent is going to give us 1. So we could actually write that down as a rule. 1 to any power equals 1. It gets trickier if we've got something like negative 1 to the power of 5. Okay? And I'll just do the next example, 1 to the power of negative 4. If we've got 1 to the negative 5, we've got negative 1, negative 1, negative 1, negative 1, negative 1. We've got 1, 2, 3, 4, 5 negative signs. So 2 go together to give us a positive. So it's kind of like these two will give us one positive, these two will give us another positive, and then we're still going to have a negative left over. So this is going to be negative 1 here. So we could write this kind of as a rule. Let's say something like odd exponent will give us a negative answer. So I'll just say negative answer if our base is negative. If, on the other hand, we have an even base here, an even exponent and a negative base, remember we have negative 1, negative 1, negative 1, negative 1, we're going to get these two together will give us positive 1. These two together give us positive 1. So we'll have positive 1 times positive 1 gives us positive 1 is our answer. So we can say even exponent gives us a positive answer, okay, if our base is in fact negative. And of course, remember, even if we've got something like this, okay, our base is only 1 here, so this is 1 times 1 times 1 times 1 with that one negative sign out front, just negative 1. Okay. So I would include any others in this section that you find you have trouble on if you're working through the guide. So that's all I'm going to do today. You guys are responsible for filling in the rest of the boxes. So you're going to have another topic for box C where you are multiplying and dividing. Oh, that's not how you spell dividing. Powers. So it's up to you to fill in that one. And then you're also going to have another topic where you do powers of powers. But I'll leave that for you to work on as you go through. And we're done.